1. Okay, so
Hi, Maya.
so definite integrals. Let me just explain this. This doesn't. So we actually have some review days built into the schedule this week, so hopefully you have some time to get caught up. In the meantime, definite integrals. Okay, so when we did the Riemann sums, right? Right? We had the left hand, the right hand, the midpoint, and then we also did the trapezoidal. That was just, these were approximations. It's just, that's what they're called, Riemann. That's. Yeah.
You make a deal if I don't do any work, I get an automatic B. But I still try, but we don't grade.
That sounds good.
I would do that.
I would do it too.
I'd go for a C.
No, you wouldn't.
Alright,
alright,
You can't go for what you got last semester. You have to go at least for what you learned.
Okay. So when we say the Riemann sums, we're just referring to these LRAM, RRAM, okay. Those were approximations for the area under the curve. So what we want to do is find the exact area under the curve, okay? The next class we're going to learn all the formulas for right now. The formulas that we would be using would just be like area of a triangle is 1/2 base times height, or area of a circle is pi r squared, okay? So what we're actually going to look at is some notation for functions that you can integrate. Integrate means that you can find the area under the curve. So if it's continuous on a closed interval, then we can find what's called the definite integral. Again, when I say definite integral, we're picturing the area under the curve, okay? Don't worry so much about this notation. It's basically a limit. Okay, so imagine if we took those rectangles and we made infinitely many of them. What would end? Okay, and imagine that they're going to get skinnier and skinnier, and you're going to get you're going to get closer and closer to the actual area. See, the bigger the rectangles are, the harder it is to fit under the curve. But if you have if you have like 100 of them, 1,000, you're going to get closer and closer to the area. So when we look at the limit as n approaches infinity, that's the number of rectangles. Yeah. That limit is the integral. Okay, so let me just show you some of the notation. This is the integral symbol. It looks like an elongated S. That's really what it is. It represents the sum. We have a lower limit is A and an upper limit. So that's kind of like where it starts, where it ends, right? Not the min and max necessarily. I mean, A is less than B, but we call it the lower limit. Just think this is where we start, and this is the end. And then f of x, this is our integrand, so whatever the function is, and the dx. I'm just trying to show you the notation, and then you'll learn. So dx, like if this was f of a, then you would have dA at the end. It's just these two variables have to match. So like if I had the integral of y squared plus 4y, we would want to make sure that that just has the letter dy at the end. The integral and the dx, these have to go together. Like you can't have an integral sign without a dx or a dy or a dt or something at the end. Right.
Or DP.
It could be, but basically these have to go together in order to what we say integrate. Okay, so what did I just say about all of this? We said it's the area under the curve. So the area under the curve is going to be represented. So whenever you see that integral sign, we're going to think, I got to find the area under f of x from A to B. Okay, so think area under f of x from A to B. So, just, it is too late. Thursday was the last day. Okay. So, imagine for a minute, just take like a line. Let's just say I have the line y equals x. Just as an example, and let's say I have from 1 to 3. Could I figure out the area under that curve from 1 to 3? So that would look like, so my area under the curve would go from 1 to 3. What's our function? So f of x, I just said the function, I'm just going to use x as an example. So could you figure out the area under that curve? What kind of shape do we have? It's a trapezoid. So could you divide it into like a triangle and a rectangle, or just the trapezoid? So you could actually figure out the dimensions for that trapezoid, figure out the area, and you would have evaluated this integral. Okay, it involves geometry. Let me, I'm actually going to skip to the next page. I'll go back to the calculator part in a minute.
Is that the integral sign and a comma x dx?
That's an integral with a 1 to 3 of x dx. I'll come back to the calculator part. We'll do the next part by hand. Okay, so for example 1, if you're not sure what this graph looks like, oh, and there should be a dx here, sorry.
What's the point of having the dx?
You have to have the integral sign with the dx. You can't just have an integral sign. Here's the reason is if you have, like, let's say a constant, you need to know what variable it's kind of like related rates. Remember when we did like d, dt of both sides? It's important what you're differentiating with respect to. Same thing for integration. It's important to know what variable you're integrating with respect to. It'll make more sense when you see the formulas.
Dx is not the derivative integration.
No. So I'm going to graph this here, 4 minus x squared under the square root. This actually looks like a semicircle, if you didn't recall from the beginning of the year when we did some review. If you're not sure, just you can graph it on your calculator. But it has a radius of 2. Now, if there was a negative sign in front, it would just be the lower portion of the circle. Now, I want the area under the curve. Now, when I say area under the curve, it stops at the x-axis. So we're picturing this region.
Did you plug it in, or did you plug it in your calculator?
No, I don't want you to use your calculator for these. These I want you to do with finding area. Well, what's the area for a semicircle? It's 1/2 pi r squared, right? Pi r squared is an entire circle, so half of it would be, so my formula is going to be 1/2 pi, what's the radius? 2 squared, so we get 2 pi. Now I'll show you, you can check your answer on your calculator. So if you have your calculators. Okay, this is the directions for this are on the previous page. So do you remember how to do the derivative? It was math and then the number 8. This is going to be math and then the number 9. You see here? So if you hit number 9, and you basically just put in
Physics sucks.
what? -2 and 2. Just use your arrows. Oh, never fails. Okay, -2 to 2. Yours looks different. Okay, I'll tell you how to do that too.
Upgrade it.
Yeah, I upgraded. I got the
I did. I just got.
This is Carmel back.
Okay, the three of you that are actually typing this in, what did we get?
Do you want to graph it?
What did we get?
Are we graphing this?
No, you can graph it. Okay, I'm gonna show you two different ways.
What? I got a different one.
You must have forgotten something.
How do you do this?
So if you have this one, where it shows up like this,
To no purpose, so it's yeah, 83.
so do the square root, and then put a comma, and then put x, and then put comma, -2, comma 2.
Do you always assume that
Okay, one person at a time, I can't hear. Yeah.
you always assume that the x-axis is the limit?
Yes. Okay. Otherwise, everything would be infinity.
It throws
my Right?
calculator.
If it never stopped below, everything would be an infinite amount of area.
6.2.
If it didn't stop.
If you were to have a complete shape, that's where it's based.
Oh, sometimes you do have a complete shape. We'll talk about that also.
Oh, does it need to graph it like in its internal memory before it says
Yeah, I got
Okay,
It takes a long time.
let me, yeah, it does. Okay, you can also do this by graphing. If you put in the square root of 4 minus x squared, and then let's graph it. Let's graph it in standard.
How do you graph this in the 83?
Same way. The 80, oh, this is for the 83 here, if you're just doing it by hand. But this part is the same no matter what type of calculator you have, TI 83 or TI 84. So we're gonna go to second trace. That's where you calculate. You see the bottom one, number 7, has the integral. So what's nice about this is it will actually shade in so you know for sure that you have the correct region. So it's gonna ask you for your lower limit here. So you're just gonna type in -2 and then press enter. And then it's gonna ask you for the upper limit, so just type in 2 and then press enter. And then it'll shade in, that's correct. And here is your 6.28, it's gonna change it obviously to a decimal, but that's the same as 2 pi. Okay?
Oh, no way.
How do you type in the y or
The first one, to -2, press enter. So this is, again, this is for TI 83 or an older version of TI 84 that doesn't have the update. Okay, I'll have to come check. Let me just get through the lesson and then. Okay. Now, what happens if I'm finding area? Okay, and I ask you for the area of something, but it goes below the x-axis. So when f of x is less than or equal to 0, that's when it goes below the x-axis. So anytime, guys, if you pay attention, above the x-axis is a positive area, or is a positive integral. Below the x-axis ends up being negative. So let me just explain. For example 2, okay? We want to integrate from -3 to 3. So I want to find the area above and the area below. Any area that's above, this is going to count as positive. Anything that's below is going to count as a negative. Okay, so here, from -3 to 3 of f of x dx, I'm going to look at from -3 to 0. And then, what do I want to do? Now I'm going to add, well here, let me just show it like this first, and then you'll see. Actually, let me write this. So this will be negative. because it's below. This will be positive. So this, it's just a triangle. What's the base?
What's positive?
This is positive. Just remember, if you're just evaluating the integral, I'm not asking for the total area or anything like that. I'm just asking you what is the integral. So we want to count this as a positive area, this is a negative. So here, what's the base of this? This has a base of 3 and a height of 2. So base times height divided by 2. So 3. And this is actually going to be, well, it has the same dimensions, but it's going to be subtracted because it went below the x-axis. So you actually get 0. It's kind of like the area above and below canceled each other out. So that integral is actually equal to 0. Right, that's actually what I wrote here. I kind of like to think of it as just anytime it's below the x-axis, it's going to be negative. But if you wanted to think of it as a subtraction, it's the same idea. Yeah.
Can you give me more? Because I would think I have a height of 2.
Oh, so you like to make it as a subtraction?
That's probably better.
Okay. Either way, it's the same thing.
You're not saying that the height is negative?
It's just, okay, so technically the integral from 0 to 3 is negative because it's below the x-axis. You see this here?
Yeah.
Anytime it goes below, this is going to be a negative integral. This part here is positive because it's above. So picture like the x-axis as like where it cuts it off. So anytime it's above, it's going to be positive. Anytime it's below, it's negative.
How long is the x that makes it in reference to the
Yes. Yes. Okay. So if you have a constant, right? You'll always have a rectangle. We already did this. This was the very first example that you did in the notes packet. Remember the train with a constant rate was going 75 miles per hour from 7 a.m. to 9 a.m. So what was the area of that rectangle? It was 75, right? Times what was the length of the subinterval? It was 2. So you just multiply. Okay. Oh my goodness.
Why is the line on here?
Okay. So the way that would look with integral notation is you would have the integral from 7 to 9 of 75 dt because this is with respect to time. So you basically just look at the difference, 7 and 9, so 9 minus 7. So you get 150. That's just how it looks like in notation. Okay, so let's use that idea of when this is a constant. So what would example 4a be? Oh, did I? Somebody's at it. Negative 6 times 4. Which is?
If we're working on constant, can you still bring that down like do like 7 minus 3
No.
times
It's evaluated different. It's only for constant. What about this one? What's that? No, don't worry about units. Okay, the only time you have to put units is if it's a word problem or if they give you units within the problem, but otherwise it's just a number again. Okay, so this one, pi over 2, what's the difference between -1 and -4? 3. Because remember, it's going to be -1 minus -4. So pi over 2 times 3. It's always the top minus the bottom for the limits. the limits of integration, top minus the bottom. So we get 3 pi over 2. Remember, these are the types of problems where you could just plug this into your calculator. Notice it says d theta. You could just make that dx for this one. It doesn't really make a difference in. Yep. This one? Yep. It's below the x-axis, so it would be, yeah. It just means like your area will end up being negative.
Oh, so you wouldn't.
Okay. Let's look. Yep. Nope. So on the next page, we're going to graph, okay, whatever the integrand is. And we're just going to look at the bounds. So like the first one goes from 0 to 1. You can graph the whole line if you want. What's this? Think y equals mx plus b. Right, so we start at 4, and it goes down 2 over 1, down 2 over 1. So here is the line. We'll keep going. But I just want to look at from 0 to 1. So basically, I'm looking at from here to here. So I want this region. I don't worry about this little triangular region because that goes to 2. Okay, I just want the area under the curve of this line between 0 and 1. So what kind of shape did we end up with? Trapezoid. So could we figure out the area of that trapezoid? Yeah, it's 1/2. What's the height of the trapezoid? Careful, it's on its side. The height here, it's 1. And then base 1, that has a length of 4. And base 2? So 1/2 times 6, so we get 3.
And that gives us the area.
That's the area under the curve from 0 to 1 of negative 2x plus 4. And you can plug this into your calculator to check. There's no units for these. Okay, how about the next one? 1 minus absolute value of x. Okay, it's an upside down V that's moved up 1 unit. So it looks like this. The more accurate you can draw it, the easier it is when you actually have to find the area. If you're not careful when you're graphing. Now I just went from negative 1 to 1. So basically I'm going to ignore everything else. I just want to graph from here to here. It's just that little triangle. I don't think it would have picked that up. No. Something about straight lines. I didn't hear after.
All you were doing is like, the other graph.
You graph it, and then you just find the area determined by the limits.
Using the area ornament?
Yeah, it's just 1/2 space times height. That's why I said the only areas you need to do here, like the only area you need to know how to do for this lesson is a circle, rectangle, trapezoid, triangle. That's it.
So trapezoid is 1/2 times
The height, and then base 1 plus base 2.
So we're finding in between 0 and 1 because that's what's set for A, and for B we're finding in between 1 and negative 1.
have one more problem.
What? Is there, why, how many of those positives though?
Because it's all above the x-axis. There's nothing that went below the x. Now, what if I said from negative 1 to 2? Then this little region here would have counted as a negative area.
You lost me.
Don't worry about it. It would just be unit squared, but We don't have a unit for this. It would have to, it would be a word problem where it would be specified.
This is just finding the area on the plan.
Right. These here are just for your calculator.
What does this provide us
And I'm actually going to have you skip this one. But these I do want you to do. So, just plug these into your calculator, the ones that are here.
I have no idea. Even better. You can solve your 35 minutes. Road is, if there's no, so you have like 40.
Yes, so you have separation. If you find an area to curve, you have your velocity line. Kind of it. Oh, right. Okay, so you have to have a solid initial value and the initial velocity in order to actually, because we didn't the acceleration function, you can acceleration plus like velocity in order to find the velocity. And then you can work backwards again to find the Let me. No, not yet. Did you guys plug it in? What'd you get?
Well, I'm not there yet.
No, I just want you to give me the A and B. What did you get?
I don't know how to do this. I'm still trying to figure out how to do